This problem and all other practice problems for Calc 2 here at Rutgers can be found in Sarai Studies. A link is in the description box below. Does the following series converge or diverge? Well, because I see an exponential, so a constant raised to a variable, I'm going to use the ratio test because remember, factorials and exponentials means use ratio. The rules of ratio tests are based on the limit as it approaches infinity of the ratio, so a fraction of your sequence, but anytime you see an n, you're going to add a 1 divided by your sequence, take the absolute value of that, that's equal to a limit, or at Rutgers we call it rho, even though it's a literal p. If rho is less than 1, rho is greater than 1, rho is equal to 1, then this series converges absolutely, diverges, or the test is inconclusive, which just means try another test, not that there's not an answer. So we're going to take the limit as n approaches infinity of a of n plus 1. I'm going to take my sequence, and anywhere I see an n, I'm going to add a 1. Then this would be n plus 1 plus 1. Because remember, this is being multiplied, so we're adding a 1 there. So this is just this, and so we have to still divide by the sequence itself, or we can make our lives easier and just multiply by the reciprocal of the sequence, which is just flipping the numerator and denominators. And then because n is equal to 1 and all we have are n's, we know that all the terms in our series are going to be greater than or equal to 1, so it's going to be a positive series. Because it's already a positive series, the absolute value of this is still this. Now, the first step once you write the limit is to switch the denominators so that similar things are next to each other, because that way it's easier to simplify. So I would simplify this to be 4n plus 4, and so plus 1, that's 5. And then I know I can split these up to be 2 to the 4n times 2 to the 5th power, and the denominator could be 2 to the 4n times 2 to the 1st power. These cancel out, so I'm just left with 2 to the 5th power over 2. This is a constant, so we could just bring that outside the limit, and we're left with this. This can be split up to be n plus 1 to the n times n plus 1 to the 1st power, and in the numerator we have n to the n. And to simplify this becomes 2 to the 4th, and we know that's 16, and this can be split up like so, and we can treat these as different limits. This limit is easy because it's a rational fraction, so we could divide every term in the fraction by the term with the largest power in the denominator, and that's n to the 1st power. We divide everything by n, so we have 1 over n divided by 1 plus 1 over n, and when we plug in infinity, 1 whole divided into infinitely small pieces becomes infinitely smaller, so small they cancel out, be 0. 0 over 1 plus 0, which is just 0 over 1, which is just 0. And so since this whole thing is 0 and we're multiplying, then none of this matters, it's just 0. And 0 is less than 1, meaning rho is less than 1. That means that this series converges absolutely. Let's get to our conclusion. Since, then you just take the first limit that you write, is equal to 0, which is less than 1, comma, the ratio test implies given series converges absolutely. But they didn't ask us if the given series converged absolutely. They asked us if it converged, period. So that's where our number 2 tool in our toolbox comes in. The absolute convergence theorem says that if we have any series that converges absolutely, which we do have, that same series is going to converge. And absolute convergence implies convergence by the absolute convergence theorem, so the given series converges as well. So the answer is that this series converges.